Hi everyone, my name is Suali from the Stein Monogastric Nutrition Laboratory at the University of Illinois. I'll be discussing digestibility and retention of calcium in 3 different periods of gestating cells. Here is the outline of the presentation. I'm going to introduce some background and the objectives, provide materials and method, state the results of digestibility and retention of calcium and phosphorus, and draw conclusions. Let's start with the introduction of this experiment. Standardized total tract digestibility (STTD) of calcium has been introduced recently. The values can be calculated by correcting apparent total tract digestibility with the basal endogenous loss. And the values for the STTD is believed additive in a complete diet. Most of the calcium-containing feed ingredients have been evaluated using growing pigs. However, previous data showed that the values for the STTD of calcium and phosphorus are about 3 to 4 times less in sows in mid gestation compared with growing pigs. It is possible that the STTD of calcium as well as retention differ amongst sows in different gestation periods, possibly because of different calcium requirement or feed intake. Use of phytase increases digestibility of phosphorus and calcium in growing pigs, and this effect has been published in a number of papers for many years. It is also possible that the efficacy of phytase differ among the gestation periods. However, to our knowledge, possible changes during gestation of the basal endogenous loss, the STTD of calcium, and retention of calcium and phosphorus have not been reported. And it is therefore not known if values for STTD of calcium or retention of calcium and phosphorus obtained in a specific time in gestation is representative of the entire gestation period. The objective of this experiment was to test two hypotheses. First hypothesis was that basal endogenous loss of calcium, the STTD of calcium in calcium carbonate, and the response to microbial phytase on STTD of calcium and apparent tract digestibility, ATTD, of phosphorus in phosphorus adequate corn-based diet fed to gestating sows are constant throughout gestation. Second hypothesis was that retention of calcium and phosphorus does not change during gestation. Let's move on to materials and method. We utilized 36 multipurpose gestating cells. We fed the same diet during 3 gestation periods. Equal meals were fed twice a day, and feed intake was 1.5 times maintenance. Fecals and urine samples were collected 3 times throughout gestation, and digestibility and retention were calculated. During the non-collection period, sows were housed in gestation stalls. However, from day 7 to 20 as early gestation, day 49 to 62 as mid-gestation, and again from day 91 to 104 as late gestation, sows were moved to metabolism crates where they were fed one of the 4 experimental diets. Sows were fed the same experimental diet every time they were placed in the metabolism crates, but when sows were housed in the gestation stalls, they were fed a common conventional gestation diet. Calcium carbonate was a sole source of calcium in the experimental diet. Corn was included to provide phytate in the diet. Corn-based calcium-free diet was also used to measure the basal endogenous loss of calcium. In addition to the 2 diets, 2 additional diets were also formulated with microbial phytase to contain 500 units per kilogram of diet. Therefore, a total of 4 diets were used with 9 replicates per diet. Average concentrations of calcium and phosphorus in the calcium carbonate containing diets were about 0.88 and 0.58 55%, respectively, the calcium-free diet contained almost same amount of phosphorus. The statistical model included phytase, gestation period, and interaction. Since the same cells were used throughout gestation, repeated measure was also used. However, there was no significant interaction between two factors. Final model only included the two main effects. Let's move on with the results. And all of the data will be presented by its main effect, that is phytase or gestation period. Now we are looking at the basal endogenous loss of calcium from gestating cells fed the corn-based calcium-free diet. The basal endogenous loss of calcium was approximately 1100 mg per kilogram of dry matter intake. The basal endogenous loss of calcium was reduced to about 860 mg per kilogram of dry matter intake when microbial phytase was supplemented to the calcium-free diet, meaning that the phytate from corn can also bind to calcium ions from the basal endogenous loss of calcium, and that use of phytase releases the calcium from the phytate calcium complex. The STTD of calcium in calcium carbonate was 40% regardless of gestation period when no phytase was used. However, supplementation of phytase did not increase the STTD of calcium in calcium carbonate. This observation was not expected because usually phytase works very well in growing pigs. The ATTD of phosphorus in diets containing corn and monosodium phosphate was 23% regardless of gestation period when no phytase was used. It was 27% when microbial phytase was used, but there was no difference in the two values. Moving on with retention data, supplementation of microbial phytase did not affect the calcium retention. Same was observed in phosphorus retention. From now on, data will be presented based on different gestation periods. Before looking at the basal endogenous loss data, I would like to point out that feed intake increased from early to mid to late gestation because of body weight of sows increased. The basal endogenous loss of calcium was greatest by sows in early gestation, followed by sows in mid and late gestation periods, respectively. The ATTD of calcium was corrected with each value of the basal endogenous loss of calcium, and values for the STTD of calcium in calcium carbonate were 42, 28, and 48%, respectively for early, mid, and late gestation, with mid-gestation sows having the least digestibility. Regardless of use of phytase or gestation period, sows have less digestibility of calcium when we compare with previous data from growing pigs. Looking at the ATTD of phosphorus in diets, the values were 24, 14, and 36% respectively for early, mid, and late gestation, with mid-gestation sows having the least digestibility and late gestation sows the greatest. Again, regardless of use of phytase or gestation period, sows have very low digestibility of phosphorus when we compare with previous data from growing pigs. Looking at retention data from sows in different gestation periods, sow in late gestation had the greatest calcium retention, followed by early and mid gestations. It seems that sows in mid gestation regulate calcium absorption and retention because they may not need much of calcium as sows in other periods. Basically, similar story was observed for the retention of phosphorus. Phosphorus retention by late gestation sows was greater compared with earlier periods. Regardless of periods, again, gestating sows are not very focusing on retaining calcium and phosphorus in their body. However, greater retention of calcium and phosphorus in late gestation Maybe because they need more calcium and phosphorus for fetus growth. Let's move into conclusion. Based on the results from this experiment, the basal endogenous loss of calcium decreased if a corn-based calcium-free diet contains microbial phytates because of the phytate in corn binding to basal endogenous originated calcium, and this was also observed in growing pigs in previous experiments. The digestibility and retention of calcium and phosphorus are not affected by use of microbial phytates in phosphorus-sufficient diets for gestating cells. This observation is something that we should keep in mind. Lastly, there was an increase in digestibility and retention of calcium and phosphorus by late gestation cells. This may be explained by an increase in requirement of calcium and phosphorus to be used for fetus. This experiment is also published in Journal of Animal Science, so if you'd like to see more details of this work, please find the paper. I would like to acknowledge AB Vista for the financial support and all the lab members. And if you want to learn about research we are conducting in the Stein Monogastric Nutrition Laboratory, please visit our website at nutrition.nsi.illinois.edu or search Stein and Pig on Google. Thank you for listening.